Hi, my name is John Salaban. I'm here today in the School of Gymnasium to show you something amazing, something cool. The 3D printed electric go-kart. This go-kart behind me has been made out of 3D printed parts. It goes very fast and has a lot of power. And it's got cool underglow lighting. So let's have a closer look. Okay, so the first thing we gotta do is turn off these lights. Put the remote in my pocket so I don't get smashed. The go-kart is too wide to fit through the door, so we had to make this special plywood scooter type thing to move the go-kart. So let's flip it down here. It actually is quite heavy. Come around and get one wheel off. All right, and there we have it. We can scoot the platform out of the way. So I just wanted to pause for a moment and thank my students at my high school that I teach that made this project possible. I teach CAD, computer-aided drafting and design, and 3D printing classes at Antioch Community High School, and some of my advanced students helped on this project. They were a source of ideas. They helped me troubleshoot and problem solve when needed. And of course, they were great test drivers. They really enjoyed getting in the cart, driving it, identifying problems with it, and then going back and fixing those problems. So students of Antioch Community High School, I thank you for your help with this project. Okay, so I wanted to talk a moment about the filament used to print this go-kart. I did use PLA plastic. It was the eSun PLA plastic, PLA Plus or PLA Pro, as it's sometimes referred to. Amazon, $22 to $25 a roll, kilogram roll. But that's what we used in printing all these parts, with the exception of the white or the cream color part of the steering columns, steering components there. That was ABS plastic. I just wanted to use a different machine to show my students, Stratasys machine, but FDM, ABS plastic. But everything else, steering wheel, floor, rails, the front rail, all the way in the back is that PLA Plus or PLA Pro from eSun. Of course, the exception also with the motor mount bracket. That was Tallman alloy 910 nylon material. But everything else, I used the PLA Plus. And I find that that's my go-to filament for PLA at least, because it's got an additional ingredient or ingredients in it versus the normal PLA that allow it to, be a little bit stronger and not as brittle and more susceptible to tolerating moisture and things of that nature. So it's just kind of an upgraded version of PLA and definitely has worked out well for me. How many rolls did we use? I would say, I think we lost count, but I would say about 50 rolls. Between prototyping different parts, pieces, at least 50 rolls. These rails here that are structure, that important that they don't bend and break and fracture. Use almost an entire roll of PLA, so almost an entire kilogram of PLA to print. And so, yeah, it took a lot of rolls. Now, what printer did we use? Well, mostly I used my CR10 because I needed the additional height that I could print on a CR10. I use some other machines to print other little doodads, like the housing for the charger port. But most of all these parts that you see are done on the CR10. It was a very reliable machine. I did have to change out the hot end once or twice because we had thousands of hours of printing that it took to make these parts. But pretty much I was happy with the CR10. Yeah, it worked out well. Some of these parts weren't designed fully before we started. We kind of started with building these side rails. I said, okay, let's make these rails, let's put them together and add pieces to it. So when we were ready to add pieces to it, we were able to design and then make those parts. So I would say about 50% of it, half was designed ahead of time, and the other half was designed kind of on the fly as needed. So it's kind of an interesting thing to talk about in terms of design, that it wasn't fully designed on paper or in the computer before it was put together, but it turned out quite well. What I want to do now is take you on a tour of the parts and pieces and show you how we kind of put this thing together. I will start with the rear wheel here. The blue part, the wheel, was 3D printed, of course. It was 3D printed in 2 pieces and then bolted together. There is an inner tube in there that surrounds the tire and then inflate it to give it strength. The challenge with creating this was to make the 3D printed part strong enough to withstand the pressure when you inflate the tire, that it doesn't fracture the printed parts. So our first prototype fractured when we put air in it. It separated. So we had to go back and really increase the infill and of course the brims on this to make it stronger. Another challenge was to make it strong enough and accessible for the air fill and the rear axle nut. So all 3D printed. So far we've been driving this go-kart and we haven't had any sign of fatigue or cracking on this wheel, so we've been really happy with it. So we do have a rear steel axle for this, not 3D printed. And some people are going to say, hey, you don't have all 3D printed parts on this. I get that. If it was possible, I would love to do all this in 3D print, but for safety reasons, obviously, we have to have some parts of steel. So the steel axle goes through a bearing, and then it's on a flange, and then it's bolted to the rear 3D printed frame piece. What this black piece of plastic is on the outside here is laser cut ABS plastic that was super glued onto the 3D printed parts to give it added strength. But so far we haven't had any cracking or fatigue or failure of the 3D printed parts in the back. This piece was very critical, of course, because those 2 bolts right there is where the brake is attached to. The brake caliper, and then of course the disc there. And when you brake this go-kart, it is heavy and there's a considerable amount of strain. So we had to really beef up, again, high infill, a lot of brims, and then the ABS plastic on the outside of it gave it a lot of added strength. But, and the same thing over here, you can see a little bit better where the bearing bolts go through, and it's just 3D printed part. So on this side, there's no additional gusseting of the 3D printed part because the brake is not on that side. We have a large cross member back here, so the frame doesn't stretch or twist, and another piece of plastic 3D printed part going on the back. You see some additional 3D printed parts here that hold, part of the brake spring is right there, and then 2 switches here for various functions of the go-kart. So I wanted to mention something about this brake here. There's the caliper and the disc. What was happening is the disc was heating up as we were driving this go-kart considerably, and the heat was being conducted through the steel axle into the bearing onto the 3D printed parts. So we were afraid of that heat was going to deteriorate the 3D printed parts to the point where they would fracture and fail. So what we had to do is put a small DC fan underneath. I don't forget the angle. Okay. We had to put a small DC fan down there that blows a continuous stream of air onto the disc, cooling it as we drive. To remain, so the plastic parts remain, without breaking or fracturing. And actually that seemed to work quite well. It keeps that disc cool enough where you could actually hold it with your hands, versus before it was just so hot you couldn't even grab it. So that was something that we did not anticipate when designing this go-kart, something that came along when we were test driving it. So we had to add it after the fact. So we made a 3D printed bracket there to hold that DC fan, and so far that's been working. Okay, so on the back of this we actually have mounted a Windows 10 tablet. People are going to say, what is this for? Well, this interfaces via USB to the motor controller, and you're able to actually change settings of the motor controller. So this is an Ultrex motor controller on this go-kart, interfaced by this tablet, and you can get in here and change things like the under voltage. You can have the motor controller shut off at a certain voltage so it doesn't ruin your battery pack. Or you can set maximum speed. You can change acceleration settings on here, so you can accelerate slow or you can accelerate fast. You can check the total battery voltage, the temperatures of the controller. So there are a lot of different settings you can kind of change on this Windows 10 laptop, and you can do it on the fly, which means, you know, you can get out of the go-kart, kind of make a change real quick, and then press upload, and it'll immediately upload your new settings to the motor controller, and you're good to go. So that has proven fascinating to play with, to look at, you know, different accelerations and amperage draw and things like that through the interface. So yeah, here's my wiring. Kind of looks like a rat's nest, a mess of stuff, but a lot of this was planned after the go-kart was put together. So in other words, we did not have an electrical diagram we were working off of. It was kind of made up along the way, and we kept adding to it and adding to it. So it's kind of a mess, but every connection is soldered and taped thoroughly and heat shrunk, so, and fuse protected, so we haven't had any problems so far. Here's my on-off switch. So one switch here will turn on and off the motor controller. The other switch will provide you the digital readout of the batteries. We're reading about 47 volts right now, which is a little low. Usually about 50 volts we're at. Depends how fast you want to go, right? Under there you have some of the batteries. There's 3 batteries there, if you can see that, and then here there's another 2, and then there's some underneath the seat. So we run 6 batteries. These are Nissan Leaf cells that are wired in series to provide us 48 volts to 50 volts, depending on how we charge them. And they're quite robust, quite powerful, very high energy density, which means, for the size of the battery, they pack a lot of power. So that was the power source we went with. We have the capability of adding one more battery to take this system up to about 60 volts, and you would gain about another 5 miles per hour out of it. Here, this is a switch that turns on and off the interface for the USB. So instead of continually plugging USB in and out to program the motor controller, you can flip a switch and it toggles right over to the USB connection. The motor controller is back here, and I will provide in the description where I bought this from, the price, and what it is exactly, but it's an Ultrex motor controller, and so far has been running reliably for us. It's a 48 volt motor controller with a peak of 300 amperes that can go through it. So that's a lot of power. Over here we have the reversing contactor. Oops, I hit my camera there. So that device there with those 3 heavy gauge wires are coming out is basically a giant relay that'll allow this thing to do forward and reverse. So the forward and reverse switch is right here. So as you switch it, you can hear that contactor closing and opening. So another thing about the battery is on the other side here, we have these it looks like DC plugs here. These are the balance tabs for each of the individual modules. If you wish, you can connect individual chargers to that to balance each module in the pack of batteries, but you do not have to regularly. You can bulk charge. That's what this is for. This is our kind of repurposed computer connector here, right? You can plug your bulk charger into that, and it'll bulk charge the whole pack all at once. And it's rare that you actually have to balance. It's more of you can connect a multimeter to here to make sure the cells are not damaged in any way or completely not balanced from each other. But like I said, you don't have to balance them regularly, which is good because then you don't have the additional time or expense of having to connect individual chargers to that. Okay, so let's talk about the motor, engine. Is it a motor or an engine? I guess anything electric is motor. Anything gasoline or diesel is engine. Anyway, this electric motor, if you will, this is a 48 volt DC brushed motor, very powerful. I think the peak horsepower on this thing is about 20 horsepower. So you give that perspective, you know, on a 3D printed go-kart, this thing has a giant motor with a lot of power. And again, I'll leave specs of the motor and where I purchased it from. But that motor is in a cradle, a 3D printed part. That is alloy 910 from Tallman, a nylon material, of course very, very tough. We wanted to print it out of that material because we were aware of the high torque forces this motor could generate. And so it's 3D printed out of that Tallman and then bolted with a threaded rod right through the frame to the underside of it. And that's been working well for us. We haven't had any cracks in it or anything. As you may be aware, that's a very, very tough material. I'll show you the other side of it here. In fact, it's so tough that we feel confident that we can print our own sprockets with it. So that's one thing we're going to try in the future, is to print this sprocket you see here instead of it being steel. We can print it out of the Tallman alloy 910. Same thing with the sprocket down here. And we feel confident that will work, at least for a short while, just to demonstrate the toughness of that material. So the seat is just a plastic seat you can purchase off eBay, Amazon, whatever, for go-karts. It's designed for go-karts. And it is the perfect size for this size of go-kart. But I think the future, we're going to remove the seat and 3D print it out of pieces. Because we can't print one piece that large, we're going to see if we can model something in our software and then chop it up into pieces that can be manageably printed and then glued together. Okay, I want to talk a little bit about the side rails of this go-kart that give it strength and the structure. And so they're 3D printed blocks of that PLA plus plastic, all butted together. Right there is a connection, and underneath there's a connection, and then gusseted together with more 3D printed plates and then bolted through. One thing that we found is that the plastic did bend slightly, so we got some ABS sheet. That black piece there is an ABS sheet that was laser cut with the exact dimensions of the 3D printed parts and the exact location where the bolts have to go. And then we're super glued on both sides of the frame there to give it added strength. And we found out that that prevented a lot of the bending that we had. And then the floor is so thick, it also gives it strength to the frame. So here is our main shut-off switch. You do that, it will shut off power to the rear wheels. In the event of a stuck throttle, or if the motor controller fails or something, this will remove power immediately to the rear wheels and you can stop. This thing won't short shock you. There's 48 volts going across here, but it's low enough voltage that you won't get a shock. But that turns on and off the rear wheels. So we have some more switches here. This first one here, if you push this, that'll turn on our GPS speedometer. Okay, so the speedometer will work well outside where you can get a satellite signal. It won't work inside this building, concrete and steel. You can't get a signal, but outside you can easily get a signal and see how fast you are. I think one problem that we had at figuring out a speedometer is we were looking at bike speedometers for a bicycle, and these tires, wheels, are too small to calibrate easily with a bike speedometer. So we had to go with option B, being a GPS satellite, but that works well. The other switch on here, push button switch, is not connected to anything right now. It is there for any future additionally electric parts that you want to put onto here. It's already pre-wired for that. Okay, it's time to talk about the front wheel. The front wheel is very similar to that back wheel. There's the back wheel. Front wheel, gray wheel. I had to be designed a little bit differently because instead of a live axle for the back part, right, we have a bearing in the front that allows the wheel to rotate freely. So there's a bearing. Take that nut off. There's a bearing behind there. So we had to add space for that and make sure the structure behind it or around it was strong enough. Again, we had to add space for the fill needle valve. You can see where the wheel halves fit together. So very much like the rear wheel, you have two halves, 3D printed pieces that fit together to make the front wheel. Works quite well, and we haven't had any problems with it so far. Very, very strong. So here we can see some steering parts. This is just a bottom bracket where the steel, steering shaft goes through, allows it to rotate. That's actually made out of ABS plastic. That was printed on my Stratasys machine, just because I wanted to show the students a different method of printing. And then, support coming down, and the angle support here. The white part there is ABS plastic, and the blue part is, of course, the PLA plus. You can see the wire from the speedometer that goes through the floor. So I just wanted to highlight these steel components that we used in the steering mechanism. This would be the steering column, and it comes down to these swivels, and they connect to the tie rods and go to each wheel. We are able to purchase those from a go-kart supplier, and again, in the description I will put the link to these parts and pieces that we used for these steering components. So here's the steering wheel, the green steering wheel. It's removable. As we put the go-kart on the cart, the little scooter cart, to move it through the doorway, it's easier to remove the steering wheel. But yeah, that's the steering wheel, made out of PLA, of course. It's a 12-inch diameter, printed on the CR10. That was the largest printer that we had that could print. There's a little castellated nut that holds on the steering wheel to the spline shaft. Very strong, high infill, high brim, and it's awesome. This is the throttle. Here's the brake lever, and it's just your run-of-the-mill steel go-kart brake lever for your foot thing, and it's connected to a 1/4-inch diameter, I believe, rod. It runs up to the caliper, so it's just mechanical pull on it that will activate the caliper there on the disc. But again, because of safety involved, we wanted to make sure that part of the braking system obviously was metal for safety. I think the plan is in the future to replace the foot pedal there with the Tallman 910 alloy material, using that material that can withstand, the pressures from your foot. Okay, so last but not least, the underglow lighting. The students insisted that we had underglow lighting just to add to the coolness factor of this thing. So I have in my hand a remote, and if you point it towards the back of the car and hit it, it turns on. And there you can kind of see it coming through. Of course, you're able to change the colors of the underglow and do different lighting features of it. So that's just a cool added neatness factor. Okay, I thought I'd mention it because we're probably going to get called out on it. This plywood underneath here. So that silver thing there is another battery, and underneath that is a piece of plywood. People are going to say, why do you have plywood on your 3D printed go-kart? This is all supposed to be 3D printed. Well, the plywood came about by accident. That was added to the frame as we were waiting for additional parts to be finished printing. So the plywood provided a strong structure so we can later add the 3D printed parts. It is the ultimate goal, of course, to remove the plywood and to finish the floor with these blocks. Okay, the moment everybody's been waiting for. Let's drive this thing. So I got my underglow lights on because you go faster with lighting, right? I check my switches. One switch is for the motor controller and it's on. The other switch is for the voltage. I'm reading about 46.5 volts. It's actually a little low on voltage, but that's okay, because for the purposes of driving this thing indoors, that's going to be fast enough for us. Come on over and take a seat in this thing. Get my feet situated safely on the brake. The other, my right foot just kind of hangs out here because the accelerator, of course, is on the steering wheel. And let's go for it. So the first thing anybody driving this would notice is how quick the acceleration is. Being an electric motor, of course, you have that instant torque, instant speed. Kind of feels like a roller coaster, if you will. It really throws you back into your seat. Now, I don't have a GoPro or anything, so I'm holding the camera here and trying to drive the best I can, but get this thing a little bit sideways. Brake works. That's your reversing switch. Now, I'm not going to go full speed in reverse, but just to show that it does work, there's reverse, and of course a flip of it. Wow, this really is fun. I could stay in here and do this all day, but of course you got to get this thing outside. That's where the fun will come in, because you have more area to go fast. Yeah, that acceleration is. If I kill it and if I pull back on the throttle too hard at once, evidently the chain will jump on the sprocket. And again, with that Windows 10 computer back there, the tablet, you can control the acceleration, the speed. So if you want to put a child in here, and you could turn down the speed, for instance, so it'd be a lot safer. You could turn down the acceleration so you're not thrown back into the seat. How are those 3D printed wheels looking? There they are. I'm leaning to one side and I'm really feeling the wind. Cool. Well done. See if we can get another good shot of driving this go-kart. Wow, that was phenomenal. Every time I get in this go-kart, I'm impressed by its speed, by the acceleration, the ability to stop it rather quickly, which is a good thing. So overall, this thing is performed excellent. Very good. I'm happy with the design. There's some things I would change, of course, if I had to do it again. My students and I are already thinking about the next go-kart to make, what we would do differently, how we would shape it differently, make it stronger. Well, my friends, the day is over. That was a lot of fun, but it's time to go. I got the go-kart back up on the scooter dolly mover thing so I can get it through the door. But if you watched to the very end, thank you. I appreciate it. We plan to put out more videos about this go-kart. I like to break down the parts and pieces and show you how we design, 3D print, and put some of this together. Give you some ideas maybe so you can create your own project. And then of course I want to get outside and take it on the blacktop, open it up, do some speed trials to see what the top speed of this thing is. That should be a lot of fun. So look for those videos in the near future. But until then, this is a wash. Thanks friends for watching, and have a nice day.